The Fuzzy difference, the most important is Matani Fuzzy inference and Sugano Fuzzy inference. These two kinds. This kind is more for the induction control or real-time response for the Fuzzy system. And Matani also is very traditional Fuzzy. So in this chapter, that we introduce about the traditional Fuzzy reasoning method. Is the reasoning still be used today? The answer is yes. Even now, you read the Fuzzy paper, they implement some system and introduce their methodology. Also use the Matani, but sometimes they combine with Fuzzy, not just only Fuzzy, combine with the genetic algorithm, combine with maybe CNN model, or combine with the neural network to the Fuzzy system. So in this chapter, we hope to introduce about how the operation of the Matani Fuzzy inference, and based on the Matani Fuzzy reasoning, the Sugano Fuzzy inference that you can easy to understand because they just only make a little modify about the Matani. And we have a test for study. Fuzzy inference. The most common used Fuzzy inference technique that is early that is also called the Matani method. In 1975, the Professor Matani that from the London University built one of the first Fuzzy systems to control a steam engine and a boiler combination. They applied a set of Fuzzy rules supplied by experiments human operators. Matani style Fuzzy inference process is performed in 4 steps: qualification of input value, rule evaluation, aggregation, the rule output, and finally dequalification. So this is the step, the 4th step of Matani style Fuzzy reasoning. So we can find this example how the 4th step operation. For example, here, if rule S is H3, Y is B1, H3 and B1, C1, that is linguistic variable. So we make it, this rule to a real world of the rule is like this. If project funding is adequate or project staffing is small, then the risk is low. That means the 这个计划的经费是合适的专案的职员人数是少的then the risk is low. That means at this condition to execute the project the project, then the risk is low. Be careful, here is all operation. All means in Fuzzy, that is to find the maximum value in the feature. And this one is another rule, that is A2, B3, and A2 here is marginal, and B2 here is large. So the project funding have a membership function adequate, have a function marginal, and a function inadequate. That different membership function of the system. So if we use the first step of Madani system is to quantification. So we need to mapping our problem of linguistic variable to the membership function, to a membership function. That means quantification. Then your problem be quantification. So here A1, A1 we means that is adequate. A1 is adequate. A1 is inadequate. Inadequate. Here. A2 is margin. Adequate. So A1, A2, and A3 are about the project funding. Project funding. The linguistic of the project funding. And Y is the step, number of steps. Step is the large or small. So has two membership functions, large or small. So for solve the Madani, use the Madani method. Now first step is quantification. And then we find the next step. Next step we do the rule evaluation. Rule evaluation. Rule evaluation is based on the membership function and based on the end of all the operation. And we select the minima or select the maxima. So the rule evaluation. Based on this, we try to find that is all operation or end operation. So for the rule here, X is A3 or Y is B1. A3 is the membership function here. B1 is membership function here. We do the O operation. A3 its value is 0.0 and here is 0.1. Then the O operation maximum is 0.1. 0.1 mapping to the membership function. Now we find that we more belong to the C1. Belong to the C1. It belongs to C1 is 0.1. And the rule 2 is end operation. End operation here is select the minima. Select minima, this select this one. This one. Not because this rule is mapping to C2. Rule here is mapping to C2. So its value is on C2. So, and the third rule is mapping to C3, but the only one condition. So no N and O operation. And then we have five, for example, if the three rule defined, then we need to summarize the result. In this step, we do the rule evaluation, but we need to summarize of them. So now the result of the consistent evaluation can be applied to the membership function of the consequent. Consequent. But when we mapping with some kind, the most common method of the correlation the dual consequent with two value of dual and system is to have the consequent membership function at the level of n system 2. This method is called clipping. Since the top of membership function is slide, the clip fuzzy set loses some information. However, clipping is still often perfect because it involves less complexity. And we can find this, what is clipping, and another term is scaling. Now we from a graph to explain it. For example, here the membership function, because your membership function value only from 0.0 to 0.2. So this part is not useful. Not useful. So if we make it, that value is very small. Value is very small. So if we try to make it more easy to separate the different conditions, we can make this figure to this one, to this one. To this one, how we make it? The mapping is from here. So we change, we just change the slope, change the slope to this area, because that will be easy to separate the different conditions and make it very. You also can normalize it to 1, and then the range we can. But the net is still the same membership function. That only need to a mathematic convert can do it. So in many research, when we do the research for paper, because the scale is not easy to separate the data, we need to make it or sometimes transfer to different domain. For example, support vector machine. On 2 dimensions, we cannot separate the data. We change and move it to 3 dimensions to separate the data. That is similar idea. That the clip and scaling the clip and scaling the membership function. So the third step is aggregation of the dual output. Aggregation means to summarize. Summarize which one? We try to summarize the 3 results. This one, this one, this one. To summarize the output. Because sometimes when you run it, that may be multiple rules are fine. Fine means issue. Some rules are issue. So we summarize the result. But how we summarize it? If we summarize based on this figure, we can find this new figure of the summation. Summation also based on the time slope. This point at this point at this point and find this point. So we can add some time and the shape became like this. Okay? Making point by point to add, summarize, and we find the figure of right side. And the last step is defragmentation. Defragmentation means that we try to find, because this is a multi-value. We don't understand what the real value is. We hope the output is a single value that we can control. So in industrial control, we need to summarize or to try to find the weight, the central node, or central node, weight central node. So how to find it? That we use a formula that try to find the center of gravity. The center of gravity is based on this mathematics. In Chinese, we say that is 找出它的重心，center of gravity. Center of gravity. These two parts, the difference is here. This is based in mathematics. Here is S. Here is no S. It has the difference here. Central of gravity. So, for example, in this example, we try to find the central gravity of this figure. Now we can find the value is here. So the central gravity of this figure is this node. This node means that maybe that is high. His height is 184. In this formula, how we find a gravity? If we use the measure of the integrated method, the computation time will long, will waste time. So sometimes we transfer it to discrete computing. That can save time. So if we discrete this to sampling, some point to find the value. For example, we use the pen as scale. So we can find the first node is here. Here is high. Is here. And the second is here. And the third central node is here. Here. And here is high is 0.1. 0.1. This is S. This is S. This is the UA. So this one is we centralize in this area 4 point. This 4 point. 30, 40, 50, 60. This height is 0.2. And this top we centering also 4 point. 4 point and find this one. Because we also mapping the number of centering point. So here I have a 3, 0.1, 4, 0.2, and 4, 0.5, and we can find a way. The center of gravity is 67.4. So we find this one. So this one can be output, to be output. That is every after dividing. This value also can look a table of degrees what the value mapping to. You also can describe as the output is adequate or inadequate or something. Okay. This is the from a question. You need to define degrees variable, and then evaluate the rule. After the rule evaluate, we do the operation, and finally we find the gravity. This is the real step of the Matani method. And finally, this is interesting. Every father has 3 sons. Snake, crab, and food. And Dewi. And because let's say Dewi father, what belongs to you, but other people use it more than you. Which your name, your name. Most people use your name, but more than you. Okay, thank you for your attention. We stop here.